we can find the y-intercept, and then solving it a second time, we can plug a 0 for y and solve for the x-intercept. Plugging a 0 in, 2 times 0 would just cancel, and we'll be left with 3y is greater than or equal to 12. Solving for y, we can divide by 3, so y will be greater than or equal to 4. This is our first intercept, the y-intercept. If we solve the same inequality again, but this time put a 0 in for the y value, so we'll have 2x plus 3 times 0 is greater than or equal to 12. 3 times 0 again would cancel, so we'll have 2x is greater than or equal to 12. Dividing by 2, we'll have the x-intercept, which is x is greater than or equal to 6. So having the two intercepts, the y-intercept at 4 and the x-intercept at 6, we can graph those for the inequality. Drawing the xy axis, our biggest number is 6, so we can go out to 6 on each side. The first intercept we have is y-intercept is at 4. On the y-axis, if we go up 4 spots, that would be our intercept, or where the graph crosses the y-axis. The second point, the x-intercept is at 6. If we go over to 6 on the x-axis, that would be the intercept, or where the graph crosses the x-axis. Taking these 2 points, we can connect them. The equation again is greater than or equal to. Since it's or equal to, the line will be a solid line. And the last part, since it's an inequality, we'll shade either above or below the line. To determine above or below the line, when you have a standard form equation, you can use a test point. A test point is any point on the graph that is not on the line, and we'll take that point, plug it into the inequality to see if it works. The best test point to use is 0, 0. If we take the point 0, 0, plug it into the original inequality, the original inequality was 2x plus 3y is greater than or equal to 12. Plugging in 0 for x and 0 for y, we'll see if that point works or is a solution to the graph. Putting a 0 for x and a 0 for y. 2 times 0 would be 0, 3 times 0 is 0. Adding those, we'll have 0 is greater than or equal to 12. 0 greater than or equal to 12 is false. 0 is not greater than 12. When plugging in a test point, if it's false, we'll go to the point and shade the opposite side of the line. So in this graph, above the line would be shaded. When you plug a test point in, if the inequality is true, you'll shade the side with the point. If it's false, we'll shade the opposite side of the graph. And second inequality, last inequality for the section. We'll have 3x minus 2y greater than 6. Again, this inequality is in standard form. If you have an inequality in standard form, you can either change it to slope-intercept form, mx plus b form, or you can graph using intercepts. If we graph using intercepts, we'll plug zeros in for x and y, one at a time. Plugging a 0 in for x, we'll have 3 times 0 minus 2y is greater than 6. 3 times 0 again would cancel, so we'll have negative 2y is greater than 6. Solving for y, we can divide by negative 2, and we'll have y. If you remember from inequalities, if you divide by a negative number, like we're dividing by negative 2, the inequality will switch around backwards. So if we divide by any negative number, greater than, we'll switch around to less than. And 6 divided by negative 2 would be negative 3. So our y-intercept would be at negative 3. Solving the same equation, but this time we'll put a 0 in for the y value. 3x minus 2 times 0 is greater than 6. 2 times 0 again would cancel, so we'll be left with 3x is greater than 6, dividing by a positive 3. X would come down, dividing by a positive number, the inequality would stay the same, and 6 divided by 3 would be 2. Graphing from here, once we have both intercepts, negative 3 and positive 2, we can draw the XY graph. Our biggest number is negative 3, so we can go 3 spots in each direction. Our y-intercept is at negative 3, so we can put a point at negative 3 on the y-axis, and our x-intercept is 2, we can put a point at 2 on the x-axis. Connecting these points, we do have an inequality. The inequality is not equal to. The original inequality was greater than. If the inequality is not equal to, it means we'll have a dashed line instead of a solid line. And again, to determine what side we shade, either the top or the bottom, you can use a test point for the graph. A test point, again, is any point on the graph you can plug into the inequality, any point that is not on the line. Best point, again, to use would be 0, 0. The original inequality was 3x minus 2y is greater than 6. Plugging a 0 in for x and y, we'll have 3 times 0 minus 2 times 0 is greater than 6. 0 minus 0 would be 0, and 0 is greater than 6. This is a false statement, since 0 is not greater than 6. Again, if the statement is true, we'd shade the side that has 0, 0. If it's false, like the statement we have, we'll go to the opposite side line and shade everything underneath the graph for this inequality. And that would be the graph for this section. Title of the first section today is Review, Graphing, Systems. In this section we'll graph systems of equations, systems meaning we have 2 or more equations. First equation is y equals 2x minus 3. And the second equation, y equals negative 3x plus 1. Each of these equations are in slope-intercept form, or mx plus b form. So for each equation, we can find m equals and b equals. The first equation, m the slope, the number in front of x would be 2, or you can have 2 over 1. And the b, the y-intercept, the last number would be negative 3. Second equation, m the slope, would be negative 3 over 1. And b, the last number, y-intercept equals 1. Graphing both these equations or both lines on the same xy axis. The first equation, b equals negative 3, where the y-intercept is negative 3. So we'll start at negative 3 on the y-axis. The slope is 2 over 1. So from the y-intercept, we'll go up 2 spots, and to the right 1 spot. Connecting both those points will be the line for the first equation. Second equation, b equals 1, where the y-intercept is 1. The slope is negative 3 over 1. So from the y-intercept, we'll go down 3 spots, and to the right 1 spot, which will be just underneath of our other point. Taking those 2 points, we can connect them to get the graph for both equations. The solution, if you remember, for the graph is the point where they cross. This point will be a decimal or fraction, the x value will be to the left of positive 1 or smaller than 1, and the y value would be between -1 and -2. By graphing, we cannot find the exact answer. We'd have to solve either by substitution or elimination to figure out the exact answer. Second sets of questions and last equations for the section. First equation is y equals 2/3 x plus 1. And the second, y plus 3x equals 3. The first equation is in slope-intercept form. So we can find the slope m and the y-intercept b. The slope number in front of x would be 2/3. And b, the y-intercept, would be 1. The second equation is in standard form. If you want to, you can plug in zeros to find the intercepts, or we can also change this to slope-intercept form by solving for y. We can subtract 3x on both sides. So y equals, the x we'll put first, -3x plus 3. And now we have slope-intercept form, which we can find m and find b. M equals, number in front of x, the slope would be -3/1, and b, the y-intercept, would be 3. Taking these two slopes and these two y-intercepts, we can graph the equation for the section. The first equation, the y-intercept, was 1. So putting a point at +1 on the y-axis. The slope of the first equation was 2/3. So we'll go 2 spots up and 3 spots to the right. Connecting those would be the line for the first equation. Second equation, we'll start at +3 on the y-axis. The slope is -3/1, so we'll go down 3 spots, which will be on the x-axis, and to the right 1 spot. Connecting those 2 points, we'll have the graph for the equations. Again, the solution is at the point where it crosses. In this case, again, it is a decimal or fraction. The x value would be less than 1, and the y value would be between 1 and 2. Title of the last section today is Graphing Systems of Inequalities. In this section, we'll graph systems of inequalities or 2 or more inequalities on the same graph. First inequalities, we have y is less than 2x plus 4. And the second inequality, y is less than or equal to -3/2x minus 3. Each of these inequalities is in slope-intercept form, or mx plus b form. So we can find m, the slope of the first inequality, which would be 2 or 2/1. B, the y-intercept, would be the last number, 4. Second inequality, the slope m equals -3/2, and b, the y-intercept, is equal to -3. Graphing, once we have the slope and y-intercept. The first inequality, the y-intercept, is at 4. And the slope is 2/1. Going up 2 spots and to the right 1 spot. This is an inequality graph. The inequality is less than. If you have an inequality that's less than, it's not equal to, that would be a dashed line instead of a solid line. Also, the shading for this graph, if y is less than the equation or the inequality, y is less than means we'll shade the bottom part of the graph. Since we'll shade 2 inequalities, I'll draw arrows underneath this line to represent, we'll shade the bottom of the graph. Graphing the second inequality, we'll start at -3. The slope is -3 over 2, so we'll go down 3 spots, and to the right 2 spots. This inequality is less than or equal to. Since it's or equal to, we'll have a solid line that connects both points. This line again we can shade. Looking at the inequality, we have y is less than or equal to the inequality. From this line, less than means we'll shade the bottom, and again I'll put arrows on the line to represent the bottom. The answer to the graph is the part that's shaded in common. If we're shading below the first line and also below the second line, this bottom part of the graph would be the area that's shaded in common. So I'll shade this section, or if you shade both sections, you can shade this part in darker. And that would be the answer to the graph. Second question and second set of inequalities. First inequality, we have y is less than 2x plus 4. And the second inequality, 2x minus y is less than or equal to 4. The first inequality is slope-intercept form. The slope m equals 2 over 1, and b, the y-intercept, is equal to 4. For the second inequality in standard form, you could plug zeros in to solve for the intercepts, or if you solve for y, we can put the inequality in slope-intercept form. First step, we can subtract 2x on both sides. So we'll have negative y is less than or equal to negative 2x plus 4. And to get a positive y, we can divide by -1 on both sides. Keep in mind for inequalities, if you divide by any negative number, the inequality will flip. Less than or equal to will become greater than or equal to. -2 divided by -1 would be a positive 2x, and 4 divided by -1 would be a -4. The slope, m, number in front of x, would be 2 or 2 over 1, and the y value, or the y-intercept, b, would be -4. Once we have both the slope and the y-intercept, we can graph each equation. Drawing the xy axis. The first inequality we had, the y-intercept was 4, starting on the y-axis at positive 4. And the slope was also 2 over 1, so we'll go up 2 spots and to the right 1 spot. This inequality was less than. If it's less than without the or equal to sign, this would be a dashed inequality. And the shading again, y is less than. Less than means we'll shade the bottom part of the graph, or you can draw arrows to represent the direction that will be shaded. Second inequality, b, or the y-intercept, is -4. And m, the slope, is 2 over 1. So we'll go up 2 spots and to the right 1 spot. This inequality was originally less than or equal to, which means we'll have a solid line for the graph. These lines are also parallel since they have the same slope. For the shading, the inequality that we solved, y is greater than or equal to the inequality. Greater than or equal to means we'll shade above this line. Or again, we can draw arrows to represent the area that we'll shade. The common area or solution to the graph, if we have to shade below the first line and above the second line, the common area that's shaded would be the part in between the lines. And again, you can shade underneath the whole line, above the second line, and in between the lines you can shade darker to represent the solution.